Hello everybody, this is Dr. Eldek and this is experiment number 6. So far we learned how to use the analog discovery board, the waveforms, P2 spice, how to read resistance, and how to connect circuit using breadboard. Today we'll have a real circuit and we'll see how to connect a source and measure the voltage using analog discovery board and waveforms and using multimeter. So imagine that you have this circuit. We need to build this circuit first. Convert this one here to this circuit shown below. And this circuit is similar to the circuit that we did before in one of the previous experiments. I believe maybe number 3. So what we need to do here is that we connect the input to what? We need to connect the input to source because we need to connect the source to this circuit. The source is DC and it's called VS. And this VS is variable, so it could be any value. Could be, for example, here it is 2.5 volt, 5 volt, 7.5 volt, and 10 volt. So, in my opinion, it is better to use, for example, the wave generator, because in this case you have the ability to select these values 2.5 and 7.5. Then you connect these two wires here to the source. You connect them, for example, to yellow and yellow with white strip. So this one is yellow with white strip and this one to yellow. Or you connect this one to black and this one to yellow, for example, channel 1, with the number is less than 5. And also you need to measure this voltage to display it, or to measure this voltage to make sure that it is the value that you have here. It's 2.5, 5, or whatever. So you need to measure it. So you connect it to the orange and orange with white strip. So this channel number 1 for measurement. You connect it to the multimeter or the voltmeter. And in the other side, you want to measure the voltage across this 4.7, and then you want to measure the current also. To measure the voltage across this 4.7, you need to connect it to two devices. Number 1, you connect the blue and blue with white strip to channel number 2. This channel number 2 with a voltmeter. And also at the same time you connect it to the multimeter, or you measure the voltage using the multimeter. If you don't want to connect, that's fine. You can just connect the multimeter like this. Then in this case, you will measure, have 3 measurements. Channel number 1 for the source, channel number 2 for the voltage across 4.7, which is VO, and also the reading of the multimeter, which is another reading for VO. This is what we need to do. So let us read what we have here. Channel number 1 is used to measure the voltage, VS. Channel number 2 is used to measure VO. And we use the multimeter to double measure VO. Okay? And then explain how to use analog discovery board and waveforms to make VS, as I explained before. So you can, for example, use yellow and yellow with white strip and use it with the wave generator. Okay, for 2.5 it's just one channel is enough, or you can set the other channel to be 0. So you can use yellow and yellow strip, okay, and set one of them to be 0. Let us, for example, explain it here. So assume that you have these two. One is yellow. There is one yellow. Oh, come on. Was white, and the other one is yellow, for example. So this one is yellow with white strip, like this, and the other one is yellow. Okay, so what is the voltage? Both of them will be DC. So if you make this one is 2.5, and this one is 0, okay, then the difference is 2.5. And if you make this one is 5, and this one is 0, then the difference is 5. If you make this one is 5, you cannot have more than 5. And make this one negative 2.5 volt, then the difference will be 7.5. If you make this 5, and this one is negative 5, Okay, then the difference is 10 volt. So this is how you generate these voltages here. So in all the cases, you connect this one to the ground here, and the other one you connect it to the other one, the one on the top. Okay, so this will be the source, yellow and yellow with white strip. Okay, and every time you change the value of the DC, for example here 2.5, 5, 5, 5, and in the yellow with white strip or channel number 2, 0, 0, negative 2.5, negative 5 to generate the voltage that we need. So what we need to do is to measure the voltages across or this voltages channel number 1, channel number 2, and the multimeter, and fill this table. For 2.5, what wires you will use? You have to write them here, as I explained before. And what is the device? The device is wave generator, for example, wave generator. Okay, same here, same here, same here. They are all the same. Wave generator. Okay, the same wires also we are using the same wires, yellow and yellow with white strip, and all of them the same. And then you read the value here for channel number 1, channel number 2. Of course, channel number 1 will be the same like the source, so it's supposed to be the same. This one is 2.5, this one is supposed to be 2.5. This one is 5. This one is 7.5. This one is 10. Of course, could be different, a little bit different. Instead of 10, for example, is 9.98 volt, for example. So that's fine. There must be some error, no problem. Okay. And then channel number 2 and channel number 3 should be close to each other because they both measure the voltage VO. Okay, but the multimeter usually give different result from the analog discovery board. So we will get similar results or close results for channel 2 and the multimeter. Okay, so is there a major difference between channel 1 and the source? No, should not. Channel 2 and the multimeter? No, should not. Okay, so no, no, no. And if the answer is yes, of course, this means that there's a problem in the measurement or the problem in the connection. Then you need to repeat the measurement again. When you change VS from 2.5 to 5, 7.5, and 10, what do you notice? Because this is a linear circuit, it's linear, and then the relation is linear. When you double the voltage, you double the measurements. So assume, for example, that channel number 2, I don't know, maybe this one, I believe should be 0.86, if I remember right. 0.86 volt, for example. Yes, sorry, this is supposed to be yes. So the voltage, for example, here is supposed to be 0.86 volt. Okay. Then when you double the voltage, you make it 10 volt. This 0.86 will be multiplied by 2. 0.86 times 2. 1.72. This is supposed to be 1.72 volt. And when you make it half, instead of 5, you make it 2.5. Then this one will be 0.86 divided by 2. Okay, it will be 0.43. Then this reading will be 0.43, and so on. Then you can expect the value here. Of course, it will be this number here multiplied by 3, because 0.25 multiplied by 3 will give you 7.5. Then this number multiplied by 3 will give you the voltage here. Okay, the same for this one also. The same for the multimeter, because the multimeter and the channel 2 are measuring the same voltage. Okay, see what's next. So the current measurement, for the current measurement, if you want to measure the current, there are 2 ways to measure the current. First is to use the multimeter. Second is to use the analog discovery board using Ohm's law. Of course, if you look at the previous slide, assume that you have this channel number 2, or let's see here. This, for example, I know this voltage, VO. What is IO? IO is VO divided by IO equal VO over 4.7K. 4.7K. Then, of course, the current will be in milliampere because the resistance is in kilo ohm. Okay, so this is one way how to measure the current in analog discovery board. Use Ohm's law. Measure the voltage divided by the resistance. This will give you the current. The other solution is to do what? Is to break the circuit. You break the circuit here, for example. And then when you break the circuit, you have 2 points connected together. When you break it, you create 2 points. Then what you need to do is to connect the multimeter between these 2 points. Between these 2 points. Okay, so and then you set the ammeter, your multimeter, to measure current. So how do you set it to measure current? So first we need to select the right one. There it is. This is voltage. Voltage. Okay. This one is what? This is the voltage also. Okay. This is ohm. And what's this? This is capacitor. Here, this is a current. So this is a current, but this is a high current. You do not expect high current. You expect a current in milliampere. Then you have to select milliampere. See, milliampere. And next part here is to do what? Is to check that this is connected to the right place. The probe, the red probe, is connected to the right place. You see? So of course you have to connect it to the one in the middle, red. This one here. This one. You cannot connect it to this one because this is voltage. Okay? So let us connect it to the one in the middle. And now, when we break the circuit, we connect the multimeter between these 2 points. We connect the multimeter between the 2 points. Okay? Now let's see. So to measure the current, okay, disconnect the circuit. Disconnect the circuit. And the disconnection will create 2 points, as you see here. These 2 stars here. You see 4.7, I moved it to another direction. Then now these 2 points are not connected anymore. Okay, so what you need to do is to connect them to the multimeter and set the multimeter to measure current. Then in this case, you can calculate the current or measure the current. So for the same voltages also, the same values, 2.5, 5, 7.5. Channel 1 will read the voltage, so should be the same like this. Should be close to these values. Same, because this channel number 1 is the voltage. Okay. Channel number 2 is to measure the voltage across the resistor. So this is supposed to be connected to channel number 2. Channel number 2 is supposed to be connected here. Or you can just get the reading from the previous slide. So here you get the reading from the previous slide. Okay, this channel number 2. And then divide this channel number 2 by 4.7 kilo ohm to measure the current in the 4.7 kilo ohm. Okay, so this will give you the current using Ohm's law. And at the same time, in this one here, you set or put the values here. Okay, so one way to do that is that you skip all this part here. Okay, you copy this part from the previous slide or table, and you divide the reading channel number 2 by 4.7, and all what you have new here is to do this part here, this part. is to measure the current using the multimeter. Then you compare these two values. You must get the same answer. You must get the same answer. So here when I said, did you get close values in for the column, which is this one, and the fifth one, multimeter reading? Yes, of course, it's supposed to be yes. Okay. Explain why. Because what I did in column number 4 is that I calculated the current using Ohm's law. So of course the reading, channel number 1 and 2 reading divided by 4.7 is the current IO. Then last one here, why you change, when you change VS from 2.5, what do you notice? You notice that you double the values. From 2.5 to 5, you double the value. When 2.5 to 7.5, you triple the value. 2.5 to 4, multiplied by 4. So the answer should be like this. Each row will be multiplied by 2, 3, 4. Why? Because these are linear circuits.